Hello everyone. So today I am going to discuss the design of this is comes under the lab experiment 4, lab 4, design of active low pass. Okay, through 220 steps. Before this, we have already discussed 3 lab experiment in the class. So today I am going to discuss the design of active low pass filter through LTSpice tool here. Okay. So before going to design, first of all, I would like to discuss the things in brief here so that you can recall whatever I have taught in the class. Okay. So first of all, I will going to draw the circuit diagram, whatever we will going to simulate. Okay. So CB open. This is input resistance. This is the forward resistance, feedback resistance. Sorry, RF. Okay. This is my inverting, and this is my inverting terminal. Yeah, from the non-inverting terminal, we will going to connect R and C. Okay. And from here, we will insert the input. This terminal will be complete. And this one is the output. And this is the this circuit I have already taught in the classroom. And everything I have discussed in the detail, but here I am going to only discuss the formula and response curve. So we have, whenever we will derive the mm, gain of this open, we will find the not of U is equal to 1 plus Rf upon R1. Okay. 1 plus J omega C R. Okay. This type of response gain, this type of gain we will going to do. Okay. So I want to extract some information from this gain. So I have to get the magnitude. This gain V naught upon gain is equal to, it will be going to be Rf upon R1 root under 1 plus omega s plus C square R square. So this is the magnitude of the gain not upon gain. So I want to extract some information from this. Okay. So put omega is equal to 0. Whenever we will put omega is equal to 0, our gain, magnitude of gain, V naught upon V in will be going to be 1 plus Rf upon R1. Let us consider it as a F forward gain. Okay. And again, put omega is equal to, sorry, omega is equal to infinite. Okay. And the magnitude, not the magnitude really comes at 0. Okay. So whenever we will put omega is equal to 0, it will come as 1 plus Rf upon R1. And when we will put omega is equal to infinity, it will come magnitude of V naught upon V will be 0. Okay. So based on this, let us draw the response of this low pass filter. Okay. How we will going to look like? So this is omega. This is the gain. So it will be look something like this. Sometimes it will be constant, it will be tends to 0. So this value is AF. Okay. And I want to find the critical frequency, which is also named as cutoff frequency. Named as, okay. This point is, it will be going to be AF upon 100. Okay. And this omega h, and I'm going to write it into the frequency term. Omega h is equal to, will be going to 1 upon 2 pi r into c. Okay. So these are the some of the basic concepts that will be required for design of active low pass filter. So apart from this, to design the active low pass filter, we require the value of RF, R1, R, and C. Okay. So how we will achieve this value? Now we will going to discuss about that thing. Okay. So there are some design steps for any filter. Okay. So that we will going to follow, and we will achieve the value of components, whatever we are going to use for the field design of filter. Okay. So there are some steps we will going to discuss. So steps, steps. So steps to design of filter. So our first steps will be going to be for how much frequency, we will going to design our filter. Okay. So uh, first we have to decide how much the cutoff frequency of the low pass filter. Okay. So first step is cutoff frequency specification. Okay. Second step is choose C less than 1 microfarad. Typically for our experiments, we will going to choose C is equal to 0.1 microfarad or 0.01. And the third step is we have FH is equal to 1 upon 2 pi R into C. Okay. So we have already find C, or we have already decided the value of C from here. Okay. And value of FH from the step part. Okay. Value of FH from the step. So put value value of value of value of C M FH from step 1 to step 2. Okay. Now from here we will get value of R. Okay. So we have found C, FH, and R. Now we have two unknown values, R1 and RS. So the step 4 will be A is equal to 1 plus RF upon, okay, choose here we have to decide the value of RF and R1 according to our gain. Okay, so write it here. Choose R1 and RF based on okay. So every value we have in our hand, now we can design our low pass filter. Okay. So first of all, I want to take one example and then we will proceed to the LTSpice. Okay. So let us consider I want to design, writing here. Let us consider I want to design a low pass filter which cutoff frequency is 1 kilohertz. Okay. So the first step already completed. So frequency fh is equal to 1 kilohertz. So we have already this. Okay. Now the second step, choose C is equal to 0.1 microfarad. Okay. I'm choosing it 0.1 microfarad here for our design purpose. Now third step is we know fh is equal to 1 upon 2 pi RC. From here, we can put 1 into 10 to the power 3 equal to 1 upon 2 into pi into R into C 0.1 into 10 to the power minus 6. Okay. So whenever you will solve it, you can get it the value of R equal to 1.59 kilo. Okay. Now, step 4, I want AF is equal to 2. Okay. So, what I have to take it 1 plus RF upon R1. So, let's choose value of R1 is equal to 10 kilo ohm and RF is equal to 10 kilo ohm. To get the desired. Okay. So you can choose RF upon R1, any value. Here I am taking R1 is equal to 10 kilo ohm and RF is equal to 10 kilo ohm. Okay. So now we have every value that we require. So let us draw again here and analyze the circuit again. So here capacitor C is equal to 0.1 microfarad, 1.59 kilo ohm, the resistance value. Here, from here we are applying input, the input signal. Okay, this will now RF is equal to 10 kilo ohm. This one will be grounded. And this one. So this one equal to okay. This one. And here we have to give the power supply plus 10 volt minus 10 volt. Okay. So this is all about the design of low pass filter. Now we will going to simulate this circuit in our LTSpice tool. And again, we will observe whether we are getting our desired plot or not. Okay. So this is all about the theoretical aspect of the design purpose. Now we are moving to the LTSpice tool. Okay. So here we have to append the LTSpice tool. Okay. So we have to choose every components, and we have to give the value of the component. Okay, and then we will simulate it. So to take the components, we have to go to the component section and we will type open. First, I am taking it open. So take it and place it here. Now I have to take the resistance. So I have to rotate it. Okay. Here one is going to be there. Okay. Capacitor will become picture. Okay. Then voltage sources. Okay. And then we will do the power supply. Okay. Now every component has been placed at their place. Okay. So you have to only connect the wire. Here I'm going to connect to the ground. And this power supply. Okay. Now I have to instantiate because I want to look my circuit clear. So that I am instantiating the voltage here and given the V1. This one will be the V2. Naming it to the V2. Okay. I want to name the output and the input V. Okay, so my circuit connection is now completed. Now I have to give the values to the component. This one will be 10 volt. This one will be 9 volt. Okay. The value of capacitor will be 0.1 microfarad. Okay. Now is equal to 1.59 kilo ohm. Okay. This one will be 10 kilo ohm. RF will also be going to be 10 kilo ohm. Okay. Now I am doing the AC simulation, so I have to give the AC value only. This AC value has been assigned here. Okay. So every value of the component has been assigned. Now my next task is to only simulate it or run the circuit. Okay. So whenever I will going to run the circuit, so there are lots of options will be going to be here. So I have to choose AC analysis here. So I'm taking it decade, that is points, and starting from 1 hertz to 100 kilohertz. Okay. So this one is the value I'm going to simulate it. So just click OK. Okay, I'm getting the here somewhere P out R. Okay. What's the value I'm getting? Okay. I'm define what R. Okay, I got it. Yes, I'm getting the error something like this. So V out. Okay. So here we have done some mistakes. So I have to keep the value of resistance 10K here. And this 10K will be named as R1. R1. Okay. Now I think we're going to work it. Yes. Okay. So here I have to point out probe. Now you can see the output. Now you can see this looks like a low pass filter response that we have already discussed in the class. Okay. So from here you can find 3 dB frequency. So you can check it whether it's coming or not. So uh, you can go till 9 dB. You can see it here. You can see in this place. Okay. So this one is approximately 9. So you can find it 998 hertz. That means it is close to 1 kilohertz. Okay. So this is all about today's lab. So you have to simulate this circuit. Okay. And then you have to include all the plots and the calculation in your lab file. And this plot also you have to include it. Okay. Thank you for the video.